Welcome to qnawire.
Hello friends, here as shown in the figure, there is a slender rod each of mass m and length L2A are welded together to form the assembly. The assembly is suspended by the thread from the centroid and it is to be hit at the A so that there will be an impulse of, I am marking the impulse with blue color in this direction, that will be F delta T minus J cap. We have to calculate velocity of center of mass just after impact, and you have to find the angular velocity of the rod. First we will calculate moment and product of inertia about x-axis, y-axis, z-axis and of its plane. Let us see here. Moments and products of inertia of the assembly along x direction. You can divide the assembly in three segments already given: 1, 2, 3. It will be Ix1 plus Ix2 plus Ix3. One by one you may write. So moment of inertia of assembly along x-axis would be 8 by 3 ma square. Along y-axis, first rod of second rod, third rod, m a square plus a square by 3 ma square by 3. So it will be again 8 by 3 ma square. Along z-axis, iz1, iz2, 1 by 3 ma square, 0, in the plane xz, x by yz and zx, it will be 0. First we will calculate velocity of center of mass. We have to redraw the diagram. Only geometrical view we can draw here. This is y-axis, this is the x-axis. This is z-axis. This is y-axis, you may say. This is A and this is B. So here is the impulse minus F delta T J cap. Here is the impulse due to thread. It will be T delta T J cap. That is the impulse due to tension in the wire. It will be H Z K cap H by J cap H X I cap. This is your centroid G. Impulse consists of minus F delta T J cap and T delta T J cap at G, and this is at A, and Y constraint By is 0. So by impulse momentum equation we can write T delta T J cap minus F delta T J cap is equal to mvx I cap so we can write T delta T to be F delta T. So Vx is 0, Vz is 0. So velocity of center of mass is 0. Moment of momentum Ai cap plus Ak cap cross minus F delta T J cap angular momentum along x-axis, y-axis and z-axis. So when you solve it, left hand side you will get minus A F delta T K cap A F delta T I cap angular momentum along x direction, along y direction, along z direction. So it would be Ix omega x from above equation, Hx having the value Af delta T and Ix we know already, we have calculated. You may see it. So it will be 8 by 3 m omega square omega x. So from here omega x we will get 3f delta T divided by 8ma. Now, since h by 0, so Iy into omega y will be also 0. Hz is equal to Iz omega z. Hz is minus a f delta t 2 by 3 ma square omega z. So angular velocity along z axis is minus 3 f delta t upon 2ma. So we can write angular velocity of the assembly is omega x I cap plus omega yj cap plus omega z k cap. So we can write omega x we have measured 3f delta t upon 8ma I cap 0 j cap plus minus 3f delta t upon 2ma k cap, or after simplifying we can also write 3f delta t divided by 8ma can be written as I cap minus 4k cap. So this is the answer for B part of this problem. Thanks for watching it.